would change if humans could think of any object and with that same day be able to hold that object in their hands. What kind of ideas can we as humans transfer through an object? These are the type of questions I had when I first learned about 3D printing. I wanted to learn how much potential it had. Well, most of you by now in the school year should generally know me as Charles Vidro. Something you may not know is that I'm a freelance level designer. For the past 6 years, I've spent a lot of time creating things in my head and on my computer. I'd originally started making these things in Minecraft, and that's where I developed my skills. I started off building small, little teeny houses, and as I grew into more commission-based projects, I developed my skills. In front of me, I have a bunch of 3D printed designs, and that's where I've applied these skills. So, the problem I had with making things in Minecraft is that I couldn't show anyone, really. If I wanted to show my parents, sure, I could bring it up on my computer and they go, oh, that's cool. But they would never be able to experience it at the level I could experience it in my head. So this was a problem. Cutting ahead 4 years later, during my sophomore year here at Comstock Park, my Algebra 2 teacher, Mr. Stallman, proposed a challenge to me. He wanted me to make a Christmas tree that we could 3D print on one of the Make and Bob printers at school. I was hesitant at first, but I decided to take on his challenge, and that's how I made my entrance into 3D printing. I ran into a few problems like warping on the frames or trying to remove supports, especially on that first model, and I ended up breaking a lot of things, which it happens. But as I worked through these problems, I just kept doing more prints. I did a print every few weeks, and I found solutions eventually. So, 1 year after my first print, now in my junior year, this is around December of 2016, I needed a new problem to solve. So I wanted to sort of throw back to that first model and decide to make, you know what, let's make some Christmas ornaments. But these weren't going to be normal Christmas ornaments. I needed them to have a ton of symmetry, and to do that, I wanted to define them with mathematical equations. So I went up on the internet and I found some models like this, and I'm like, okay, that's what I'm making. And I did a little bit of research and found that these were parametric and implicit surfaces. So I went over to Wikipedia and saw something like this. And I don't think any of us know what any of that means, so we're going to ignore that, and that's sort of what I did. So I went in the following day to school to talk to a few teachers and see if maybe they would know what I could make out of all this mumbo-jumbo equations, and I could not get the answer I was looking for. So I decided, I might take this on, I'll think about it. So later, a few weeks later, I was talking to Mr. Stallman about, hey, I got this empty hour in my schedule, do you have any ideas of what I could do to fill that up? So we decided to launch an independent study to kill two things at once, or I shouldn't say kill, I should say solve problems. But sometimes that is the solution. Anyways, so moving on, 2 problems. 1, fill up an empty hour of my schedule. 2, try to solve my Christmas ornament dilemma. So we launched an independent study titled Exploring STEM Through 3D Printing. Now, what does this mean? Well, this means I can take time in the school day to apply what I learned from Minecraft and the commissions and all the software I've been using and apply it to my education. So now I was able to study topics like surfaces, topology, knot theory, and molecular structure. In order to bring these concepts into the real world, I could 3D print them. But how does a 3D printer take something from the computer and put it into something I can hold? Well, it starts in a slicing software. All I do is import my model, it slices it into a bunch of layers, and it says, all right, these are where them layers need to go on top of one another. Then it follows algorithms to generate instructions for the 3D printer like you see on the screen, which we can't really read, but the machine can take that and know what to do with it. So I take that from my computer, put it on SD card, put the SD card in the printer, and then the printer says, all right, I know what to do. I'm going to take in solid plastic filament, put it through this little hole, heat it up to 220 degrees Celsius, and extrude it just where it needs to be. And it lets that plastic then go from a liquid to a solid, lets it cool, and then it keeps on moving around and stacks them layers back up in the real world. So now I was able to learn. So why does 3D printing help individuals learn? Well, it's able to do a few things that general teaching cannot. One, you can take stuff that we would never be able to acquire and just have it there in our school, ready for us to use. In addition, if you have a model, let's say I had some object and, well, I don't know what's happening with it, cut it in half. We couldn't do that normally, but with 3D printing, we can, and we can keep an original model so we don't have to ruin it. So when I went to study Pythagoras' cup, this is what I used. So now we can go back to Pythagoras' time. When he was teaching, he used to give his students a little bit of wine. He would pour it in, and as long as they took a little bit, they could drink it. So, but of course some students would get too greedy, and then once they took too much, then they wouldn't be allowed to have any at all. So, yep, that's cool, but, and you can tell that as I put it in, eventually it's all going to come out. We don't know when. So I want to learn how. So I cut the model in half, and now we can repeat the experiment again, fill it up a little bit. You can take it, and it's probably hard to see here in the back row, but from the front row, this little water or wine pours in, it comes up in inner tube, and then as long, there's another inner tube, and as long as it doesn't go over, it stays in like a regular cup. But once too much goes in, then it fills over to that centermost tube, and everything drains out. So that is one. Two, when you're studying 3D concepts, it's a lot easier to understand them when it's in your own 3D world. So I went to study knot theory, and you commonly see all these types of diagrams and tables of different knots. The problem with this is you can't tell really what's going over, under, up, or down, and especially when you get to some of these more complex models, you can't visualize that in your head from a 2D image. So, what I was able to do, actually, let me say this. Platonic solids, icosahedron. Who here knows what an icosahedron looks like, and you can tell me some facts about it? No one? Oh, just me. I'll give you a hint. It has 12 vertices, 30 edges, and faces made of equilateral triangles. Anyone? No? So, that was like me. You can't just take some word or some facts and visualize it in my head. So, I'll just 3D print it. And now I can see it from any angle I want. I can see the symmetry, and I can understand the concept a lot better. And I was able to do this with the knot theory models as well. 3D printing makes explaining some ideas and prototyping others much easier. So I saw this video on February 10th, and this is a perpetual spring engine. Now, I want to see this in my own world and actually apply it to make a turntable that would spin forever so I can display my models. But I tried, and this is what I came up with, but I never got it to work. Now, when I went back and decided, let me find out why this didn't work, well, it was a few things I had actually learned earlier in my school career. So no source can supply energy indefinitely. We know that, right? It's the law of conservation of energy. We've learned that multiple times throughout our learning career in school. Economics part. So I actually understood that in my head, but when I actually went to apply it, I forgot about it completely, and I didn't have a real understanding of what was happening. So with this perpetual spring engine, I wanted that spring to push on that blue bit with the arrow on it, and that was just going to push over. Now, what I thought would happen is the white wheels would spin against each other just because they slip and they keep on slipping. But the wheel is actually an extension of that, so it just keeps on pushing and there is no rotation of anything. And for 3D printing is just more engaging for a lot of people. So, we can take models from our head into the real world through 3D printing. It's easier to understand and we can observe it naturally. So will it make sense for an expert of a topic to be able to somehow understand and turn that into a model? How is it possible that someone self-taught in a subject can do the same thing without the experience? Well, teaching myself starts with a lack of understanding. Either a question goes unanswered at school, or I simply couldn't find what I wanted online. I didn't have an answer anywhere. So, now I have a topic that I can really learn about. Next, I need to get a general understanding of the concept. So it doesn't take a ton of knowledge to understand. I need to know this little this and this specification and these angles. I don't need to know any of that. I just have to have a general understanding of the concept. And also, you don't have to be an engineering genius to do any of this. You just have to sort of play around with it. As long as you can take the time to make the model, then you can have it. So once I plan something, then I need to find how I want to take something from my head and make it defined on my computer. So there's a few ways I usually go about doing this. One is with equations. I'll have a system equations or something where I find the zeros of an equation, and that's one mathematical way to go about doing this. So remember all the equations and stuff we had earlier? Yes? Yes, there we go. Well, we're going to do the quick rundown of how they work. So implicit surfaces, that is like this. You take a function, you set it to 0, and that's your points on the surface. If the function is less than 0, they're enclosed, they're inside the surface, and if they're greater than 0, then they're outside the surface. But we need to find the zeros of this function, which has 3 variables, x, y, and z. So we take something like a sine wave, and we'll do sine of x plus sine of y plus sine of z equals 0. And then we get something that looks like this, and you can actually see different sine waves throughout here on this domain. So we take that, I thicken it up a little bit so it can be 3D printed, and there we have our model. Now parametric surfaces are a little bit different. Parametric means using parameters or defined by parameters. So we take 2 parameters, u and v in this case, and we'll set an equation using them, and that's how we're going to define our x, y, and z coordinates. Now if we use u and v, then we get a surface like this, which is a Mobius strip, or if we just use one variable, we can get a curve in 3D space. And then once I thicken them up, that's how I can get these knot theory models using parametric curves. So there's a few drawbacks to implicit surfaces and parametric curves. One, parametrics are just a little bit weird to get used to at first, but once you understand how they work, it's fine. Implicit surfaces are very difficult to work with. Since you're just putting something in and it's finding the zeros, it's hard to guess what the resulting model is going to look like. So them are generally not used, but parametric you'll find in various workforces, making furniture, sculptures, all sorts of things. So, in conclusion, we have covered so far that humans can bring real ideas into the real world, even by ordinary people, through 3D printing. If 3D printed models are useful in helping others learn, nearly anyone willing to learn and dedicate time to figuring out these models get 3D printed. Additionally, 3D printing allows individuals to become a scientist, an engineer, teacher, and student. By using some of the smallest or randomest thoughts that come into your head throughout the day, you can create a model. Now that model, you can see it, so it goes on to inspire other people to think about whatever idea you're trying to convey. And then they can go on and keep on thinking about that and maybe make a new discovery and further educate themselves. So I encourage you to work with the random thoughts that come into your mind throughout the day. Explore them, experience them, and allow them to take you to a new place. Most importantly, show them to the world and allow others to be impacted by you